So, good morning, dear colleagues. This presentation is an answer to a number of questions asked during our last conference, but also it is more important that yesterday I was at Ramstein Air Base at the NATO Operational Space Commanders Conference, and I am not a Hungarian space commander, I was just an expert, where the question of space law again came up. NATO did a declaration roughly 3 years ago that attacks in, through, and to outer space can be a basis for the declaration of an Article 5 situation, the common defense in NATO. But where is outer space? Nobody knows. This is a serious problem in space law that we practically don't know where is the physical space we are talking about. Some say that this is deliberate. Great nations, great powers want to keep this situation unclear, ambiguous, because it suits their needs. That can be an explanation. But from my point of view, I'm an engineer. The main topic is that it is really hard to define where outer space is. We commonly understand what space flight, outer space is, but it's just an abstract construct in our mind. We need to, or we should be able to define clearly where outer space is, because only this way can be defined where the airspace ends and the effect of air law ends, where the space law effects of space law start, and possibly where the human jurisdiction in general ends. As of today, the whole universe is ours, according to space law. So there are three main theories for this delimitation. We can select a value. We can say that it's a number. 20 kilometers, 90 kilometers, 110 kilometers, or whatever. We can select a natural phenomenon and base our calculations on this. Or we can say that space is where we do space activities. That's the functionalist approach. Main problem is that these are always contradictory. In the case of an arbitrarily selected value, this is often used in national legislations, and these national legislations always contain a disclaimer that it is not the position of the nation for international applications. This is just for their internal regulatory purposes. And yes, it can be any number the legislator sees as appropriate. But different nations can select different numbers, and this can lead to conflicts in international relations and disputes. We can see the spectrum here on the screen. Belarus decided that outer space starts at 20.1 kilometers. This is most likely based on practical limitations on their capabilities to police their airspace. It is actually kind of close to the limit where human life without artificial support and life support systems can be possible. So that can be another basis. It is quite low. Very strange, because conventional aircraft can fly above this altitude. During the Cold War, the Soviet Union recommended 100 or 110 kilometers. Even their recommendation was unclear. My favorite example is the United States, where they have one definition. Sorry, that's not 50 kilometers, that should be 50 miles. That was my mistake. 50 miles, 80 kilometers when you leave the Earth. But according to NASA, when you are coming down, you enter airspace at 400,000 feet, which is roughly 121 kilometers. And it is the same country. Natural phenomena. This is often recommended for international applications. Some national legislation also uses that. Usually it is based on aerodynamics. You are in the air as long as laws of the aerodynamics apply. Or orbital mechanics, you are in space when you fly based on the laws of orbital mechanics or gravity. But no natural phenomena is stronger than the others. So how can we select one of them? Often cited example is the Kármán line, based on the calculations of Kármán Tódor, father of aerodynamics. And it is often described as 100 kilometers. It is not at 100 kilometers. It is not at a fixed altitude. And it is not the end of aerodynamics. It is just the end of aerodynamic lift, the need for aerodynamic lift. There is aerodynamic lift above this altitude. There are other aerodynamic effects. So it is not the end of the airspace. It's just the end of one effect. The lowest possible orbit where you can fly with a satellite. This is used, for example, as the basis of the South African legislation. It is roughly at 120 to 150 kilometers. Again, depends on many factors. On the current state of the higher atmosphere, the eccentricity of the orbit, the ballistic coefficient of the space vehicle. It is, again, not a fixed value. There is an interesting topic within space law, the Bogota Declaration. It was the declaration of the equatorial countries in the 1970s, where they declared that sections of the geostationary orbit lying over their territories are sovereign national territories. The rest of outer space, yes, that's common heritage of all mankind. But these sections of the geostationary orbit, they are sovereign national territories. Again, one can argue that this is a correct interpretation of gravity and orbital mechanics, but still kind of problematic. And the functionalist approach. Space is where we do space flight. But the space treaties do not define what space operations are and what space flight is. So again, there is no basis for the functionalist approach in existing international law. Usually, they say that if you fly on a Keplerian orbit, then you are doing space flight. Okay. But what about suborbital space flights that do not reach a Keplerian orbit? Suborbital in this case does not mean that it is below orbital altitudes. It's below orbital energies. But the altitude can reach out to tens of thousands of kilometers. China regularly does upper atmospheric research launches, weapons tests, but officially it's upper atmospheric research, out to 30,000 kilometers. But not on a Keplerian orbit. It's a suborbital spaceflight. It does not orbit the Earth. They launch from China and end up in the Indian Ocean without orbiting the Earth. So is it spaceflight or not? Fractional orbits. Russia experimented with fractional orbital weapons during the Cold War. Now China has fractional orbit weapons where they do launch a warhead like a satellite launch. But before it completes an orbit, they ignite braking rockets, and we enter the atmosphere. It is launched as a space vehicle, but it does not complete an orbit. So it reaches orbital energies, but then expands their energy to re-enter the atmosphere. Is it spaceflight or not? If suborbital spaceflights are spaceflight, then what about intercontinental ballistic missiles? They are flying on suborbital orbits. If ICBMs are not spaceflight, then they are aerial flights. Then air law applies. Then you need diplomatic permission to fly over sovereign territories. So if the United States, for example, wants to launch a nuclear warhead against Iran, because why not? They need diplomatic permissions from Canada, from Norway, from Russia, to fly over their territories, if it is aerial flight. If it is space flight, then is it basing a nuclear weapon in outer space or not? It is not staying there, so it is not basing, according to one interpretation. So again, the functionalist approach is not a clear-cut case, just like the rest of it. And practically, these were the problem sets. There is one proposed solution in international literature, and I personally kind of like it. It would not answer all of the problems of delimitation, but could answer some. Most of the problems with delimitation come from operations in the higher atmosphere and the lower volume of outer space, commonly understood as outer space. Roughly between 20 to 30 kilometers out to 200, 250 kilometers. This volume between these altitudes is really problematic. If you will look at the article, the journal article, I will give more examples about this topic. If we regulate this volume as a separate volume, not as airspace, not as outer space, but somewhere in between, like we see examples in maritime law. This can be a solution to many technological problems in emerging technologies. High altitude platform stations, hypersonic flights in the mesosphere, boost glide flights which change their mechanics of flight between atmospheric aerial flight and space flight. Propulsion-supported satellites that are flying on unsustainable orbits, but use their propulsion systems to augment their kinetic energy to avoid re-entry into the atmosphere. All these technologies are possible now and will be used in the near future, and they will cause many problems. Suborbital flights, they still remain problematic because of the altitude they can reach. But at least we could reach an agreement on what spaceflight is. If you fly over the protozone, as this proposal is called, then you are in space. This could be a simple solution. I really like this approach. We will see in the future whether it gets traction or not in the international community. It could solve, again, a serious part of the current problems with the lack of delimitation. And thank you for your attention. This was my presentation for today. And I will be here with you till the end of the day, so we can discuss this topic if you like it. Thank you very much.